In this video, we're going to talk about rational number exponents. So I'm going to start with the nth root of a number a. So this is the radical form. The rational number exponent form is equal to a raised to the 1 over n. Okay, so this is the rational exponent form. Okay, so n here is like 1, 2, 3, so on, counting numbers. And a here is a real number. So it's a real number, right? Okay. So rational is a fancy way to say fraction. Say I take like n divided by m. Okay, it's a fraction. That's all we're talking about when we say rational. We're talking about a fancy way to say fraction. All right, so say you've got the nth root, more general, a to the m power. Okay, to the m power. What's going on here? If we think about it, there's understood it's a 1 here, right? And so that 1 goes right there in the numerator. So this is equal to a raised to the m divided by n. But this is also the same thing as the nth root of a all raised to the m power. Okay, so once again, this is the rational form and this is the radical form. Okay. Now, this is really goofy, but it's a good way to help you remember what goes where. All right. So, m is the rider and n is the horse. Now, the rider goes in the house and the horse goes outside. Okay? So the rider is inside the radical house, all right? And the horsey is outside. It's outside in the barn, whatever, okay? So it's on the outside. Now, when you think about riding a little horsey, okay? Right, so you're riding a little horsey, okay? Who's on top? The rider is on top of the horsey, okay? So you got your rider on top and the horsey underneath you, okay? So it's goofy, but it's a way to remember how, which one goes on top, which one goes in the denominator, part of that fraction. All right. Furthermore, if you recall the rule, had x to the negative n, okay? This is 1 over x to the n, okay? So how do we handle it? If it's a to the negative m divided by n, same way, it's 1 over a to the positive m divided by n, okay? So those are the basics. Let's try to do some examples. All right, so fifth root 3 to the 10. Now, the old way of doing things, what did I tell you to do? Well, I told you, you could either divide out or you could write 3 10 times, right? And so then you say, okay, how many groups of 5? 1. 2 groups of 5 come out, therefore 2 3s come out, and I get 9, right? So how do I do that a little quicker? I look and I say, okay, there's 10 total people at the party, right? And then there's 5. Your index is 5. You take 10 divided by 5, you get 2. Okay, remainder 0, so that means 2 3s come out, and then there's no 3s left in the house. Now, what are you seeing here? Well, there was a method behind the madness of why I was telling you to do it that way, because now you see what I was implicitly telling you how to do was to rewrite your expression from radical form into exponential or rational exponent form. Okay? So remember, I'm looking at the rider and the horsey. The rider goes in the house and the horsey goes outside. So the rider's on top and then the horsey's underneath, the 5 underneath. And now all I have is 3, and then 10 divided by 5 is 2, and that gets me 9 right there. Okay? So there was a reason why I told you to do it that way, and now you're seeing it kind of play out. Okay? Let's try another one. There's always a reason for why I teach things the way that I teach them. So hopefully it will build on it and help you in the future. Okay? So now instead of going from radical to rational exponent form, let's start with the rider and the horsey, and let's put it in the house and out in the barn, right? So this is equal to, well, okay, what goes in the house? The rider's on top, the rider goes in the house, so 8 squared goes inside, and then the horsey goes outside. The horsey's always underneath, otherwise they're going to crush you, right? So the horsey stays outside in the barn just like that. So it's the cube root of 8 squared. Now 8 squared is 64, okay? And 64 can break down. All right, I need it to break down. So 64 breaks down to 8 times 8, and then I have 4 times 2 and 4 times 2. Well, the 2's I can't do anything with, but these 4's break down to 2 and 2, and then 2 and 2 again. So how many 2's do I have? 1, 2, 3, 4, 5, 6 2's. So this is the cube root of what? 2 times 2 times 2 times 2 times 2 times 2, right? So that's 2 to the 6th. That's a better way to write 6 2's, okay? So what do I know now? Well, if I do rational exponent form, that's 2 to the 6th divided by 3, which is 2 to the 2, which is 4, and that's my answer right there. So hopefully you're seeing now how to go from A to B. All right? Let's try another one, see what we can do. Here's another expression, 32 raised to the negative 3/5. First thing I do when I say a negative exponent, I say, okay, I have to do the reciprocal of whatever that thing is. So 32 is my base, so I do 1 over 32, right? So this becomes what? 1 over 32 raised to, now instead of being a negative exponent, becomes the positive exponent there, just like that, okay? Now I can work with it. I have 1 over, and then I'm going to do radical form here. And so this is what? Rider goes in the house, so 32, and then it's to the 3 power. And a horsey goes outside. What's in the denominator? That 5 right there. Okay? Now 32. Oh my goodness. This one's a bad dude right there. Now 32 times 32 times 33. You can multiply that out. That's a big number. But what do I know? This is already breaking down to 32 times 32 times 32, right? Now I need 5 to get out of the house. There's only 3 there. But what do I know? I know 16 times 2, 16 times 2 again, and then 16 times 2 again, okay? So, and then, oh my goodness, this is so many 2's. So each one of these has 4 2's, right? Oh my goodness. So how many 2's do I have total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 2's. Oh my gosh. So that's 1 over the 5th root of 2 to the 15. So that's equal to 1 over 2 to the 15 divided by 5. And that's 1 over 2 to the 3, which equals 1 over 8. Okay? So a lot going on there. A lot going on there. All right, but you gotta be careful. You gotta be careful when you're simplifying. Okay, let's try one more of those where we do the reciprocal like that. Let's do, let me choose a different color. So let's do 121 over 100 raised to the negative 3 halves, okay? Once again, I do the reciprocal whenever I see the negative exponent. So this becomes, well, what's the reciprocal of the base? That is 100 over 121. And so, excuse me, so now this becomes the positive 3 halves, okay? And so then what? What's going to happen here? Now I'm going to do that to the numerator and the denominator for both of them. So what does this become? It becomes 100 to the 3 halves over 121 to the 3 halves, okay? And so now I'm going to write it as radical form. Writer in the house, 100 cubed, and then I take the square root, and then 121 cubed, and I take the square root. Now, 100 cubed, that's 100 times 100 times 100. 121 cubed is 121 times 121 times 121. Now, to get out of the house, I need 2, and I got 2 for each of those. So I can take 100 out, and I'm left with the square root of 100 inside. And then I can take a 121 out, and I'm left with a 121 square rooted inside. Well, guess what, guys? I know that the square root of 100 is 10. So I have 100 times 10. And then the denominator, the square root of 121 is 11. And so I have 121 times 11 in the denominator. So this is equal to 1,000 divided by 1331. Okay, 121 times 11 is 1331. All right, so that's my final answer right there. Okie doke.